Go. Hello, today we are going to be learning tax and discount word problems and verbal exponential word problems. So when it comes to exponential word problems, there isn't any steps really. You just have to follow a formula and plug in the information. So this is like the entire formula you need to know. A is your final amount, P is the principal amount or original amount, R is the rate of growth or decay, should be or, sorry. And then T is the time. Next. So this is our first problem. Find the amount accumulated on $500 invested at 8.5% for 3 years compounded annually. So how we would solve this problem is that 500 is our principal amount, our original amount. And then 8.5 would be turned into a decimal, which would be 0.085. And that is our rate, and 3 years is our time. And so we need to find our final amount. So A is equal to 500 parentheses 1 plus, because this is a growth problem, not a decay. If it was decay, it would be minus. And then we plug in our 0.085, and our exponent would be 3. So how you would do this is that you would just plug in all of this into your calculator, and you will get 638.6445625 accumulated. Whoops. This number would mean the amount you would have accumulated for 3 years. So that would be your answer. This is our second problem. In 1985, there were 285 cell phone subscribers in the small town of Centralville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centralville in 1994? So how we would do this, we would do the same. I'm just going to break it down more if you don't want to use a calculator. So A, our principal amount was 285, so we write 285. And then again, this is a growth problem, not decay, so it would be plus. And we were going to turn this, and this is our rate, we're going to turn this into a decimal, which would be 0.75. And our time would be 1994 take away 1985. So now we're just gonna solve for our exponent. We're just gonna write everything down first. So 1994 subtract 1985 will give us 9. And now we have to get rid of our parentheses, but we also have to get rid of our exponents. So we would combine what's in the parentheses with the exponent, which basically means 1 plus 0.75 will give us 0.75, and multiply that 9 times will give us 153.9367942, and we multiply it with our principal, because this was previously in parentheses, and parentheses mean multiplication. And now we multiply this entire sequence of numbers, and this wouldn't be an equal to, it would be an approximately equal to. So instead of the normal equal sign will do like the two wavy signs, which means approximately equal to, which will give us 43 871 point 98637. But because we can't have a part of the person, which is what this part is telling us, we're just going to round up, which is where the approximately comes into play. And this would mean the amount of subscribers. And this would be our final answer. This is your turn. Give it a try. And now we're going to do tax and discount with Ivy.
Okay, so now I'm moving on to exponential. So the steps are knowing the function, so we know how to model the situation, know what each variable represents, and we find the value of the function after an X amount of years or the time after the situation. So here's problem number 1. Okay, the town of Madison has a population of 25,000 people. The population is increasing by a factor of 1.12 each year. How many people will be in Madison 7 years from now? Use PT as the population in Madison T years from now. Okay, so first we know we have to find PT. Our T would be 7 because the question's asking for 7 years from now. Equals to 25,000 people, because that is the beginning number. And then you have to multiply it by 1.12, but you have to put t because it's asking for the different years. So our t will equal 7 in this case. So I'll just write 7 for now, but I'll write t next to it. Equals t. So we're multiplying it by 1.12 because it says here it's increasing by a factor of 1.12 each year. Okay, then you just plug it into your calculator and solve it, which gives you 55,267.03519. But as you know, you cannot have point of a person or a fraction of a person, so you would round it to the nearest whole number, which is 55,267. So P, which is population after 7 years, would equal to 55,267 people after 7 years from now. People 7 years from now. Moving on, our second problem. A manufacturing plant earned an $80 per man hour of labor when it opened. Each year, the plant earns an additional 5% per man hour. How much money will the plant earn per man hour 5 years after it opens? Use AT for amount and T for years after it opens. Okay, so this is very similar to the first problem, but here it says additional 5%. So first, we should know our variables and write out our function, our equation. So the variable is AT. A would be amount, T would be the amount of years after it opens. Here is asking for 5 years after it opens. So for T, I'm going to substitute 5. So A5, the amount after 5 years open, equals to the original amount, which is $80. And then it's multiply. Like we learned before, we put a dot for multiplication because you don't want to put X because it might be mistaken for a variable and you don't want that to happen. So we're going to do 80 times 1.05. And that is because this, it says additional 5%. So the original is already 100%. But since it's asking for 5% more, 100 plus 5%, gives you 105% total. But we don't do percent in the function, so we'll make it into a decimal. So you know the rule is to bring two decimal spaces back. So 1.05. And then you cannot forget your t. And in this situation, our t is 5, so we're going to substitute 5 for that. But just so you know, that's our t. And then just like the other equation, we're just going to multiply it out, which should give you around a amount 5 equals to $102.10. The real answer would give you a lot of decimals after the decimal place. But as you know, in money, it rounds up to the nearest hundredth. So it would give you $102.10 for after 5 years it opens. Here are two two problems for you to practice with. You can pause the video and practice, and as always, you can ask us by emailing us, which is always on the Google Classroom, and you can always leave us some comments and suggestions on what would help you make it better. So today we learn on task and discount word problems and verbal exponential word problems. Now, as you know, today is the last lesson, but there are tutor sessions on the TC STEM website, and they are opening a new one in January called Surge 2.0. As you know, it's a Surge 1.0. So hopefully you'll keep on learning this lesson. Bye-bye. Have a good weekend.
Bye bye.